Hey, welcome to my hi-fi audio channel. I'm Zhang Hanwen, an acoustic engineer who likes vacuum tubes since childhood. In the previous episode, we covered the basic history and famous brands of vacuum tubes. Starting from this episode, we'll dive into the structure, types, and functions of vacuum tubes. Let's begin with vacuum tube diode, also known as thermionic diode. Tube diodes come in two types based on their heating methods: directly heated tube diode and indirectly heated tube diode, also known as side-heated tube diode. Let's first look at the symbol of the directly heated tube diode. The symbol for directly heated tube diode represents a simple structure. The outer circle represents the glass envelope. The flat plate-like structure on top is the anode, called plate, which attracts electrons emitted by the cathode, called filament. The protruding part down here is the cathode, called filament, which emits electrons when heated by the power supply. Now, what does the actual structure of a directly heated tube diode look like? Let's look at this brief tube diode structure. The main body of the directly heated tube diode is encased by glass envelope. The flat plate-like structure surrounding the middle and upper part is plate, aka anode. The filament, aka cathode, made of metal, is in the middle of plate. When filament connected to a power supply and heated, the metal atoms in the filament gain energy, causing the electrons in the valence band to jump to the outer conduction band, becoming free electrons. So filament can emit electrons. This process is known as thermionic emission, which we introduced in our previous episode, Vacuum Tubes History and Famous Brands. The plate and filament are connected to various structures like holder, support, and finally to the bottom pins, including pins for both the plate and filament. A base is usually installed at the bottom of the vacuum tube for protection and easy to plug or unplug. Inside the vacuum tube, you also find a structure called getter, which is used to remove stray air. You may wonder, why do we need to encase tubes by glass envelope? Vacuum tubes are encased in glass because air molecules can seriously affect electron flow and conduction. The vacuum inside ensures better electron conduction efficiency and energy use. This is also why we name it as vacuum tube. Here comes another question. Why do we usually use glass as its envelope? First of all, glass is used as it is non-conductive. Glass also has a low melting point, so it is easy to process, has high hardness, and is relatively inexpensive. Here, I only introduced brief structure of tube diodes. I know there will be a lot more contents if we discuss further. Therefore, we stop here and move on to the next topic, indirectly heated diode. Now, let's look at the symbol for an indirectly heated diode. The symbol includes a glass envelope, plate, a heater filament, and a cathode. The power supply first heats the heater filament, and then heater filament conducts heat to the cathode to make it hot enough to emit electrons. This indirect heating method is slower than direct heating method. Before diving into the use of tube diodes, let's understand their important characteristic one-way valve. Let's look at these two indirectly heated diodes. The cathode, marked K, can only release electrons, while the plate marked P can only attract electrons. Therefore, tube diode can only give one-way conduction, as the yellow arrow in the diagram. If the electron flow's direction from the power supply, which is green arrow on the right, is as same as the electron flow's direction of cathode to plate, which is yellow arrow, the electron flow is conducted. In comparison, if the electron flow's direction, which is red arrow on the left, is opposite to the electron flow's direction from the cathode to plate, which is yellow arrow, then the electron flow is not conducted. It is important to note that if the reverse voltage exceeds the diode's peak inverse voltage, damage may occur. In conclusion, in this episode, we covered the heating methods for vacuum tubes, the structure of directly heated tube diodes, the symbol for tube diodes, and the one-way valve characteristic of tube diodes. By the way, to avoid any confusion, the term tube diode I use here is also referred to as diode tube. In the next episode, we'll explore the functions of diode tube, half-wave rectifier, the structure of dual diode tube, full-wave rectifier, and the common models of diode tubes available on the market. So please like, subscribe, and turn on the notification so you won't miss out any hi-fi audio contents. Thank you for watching today. I'm Zhang Hanwen. I'll guide you through the wonderful world of hi-fi audio.